All right, so number 5 is a curling stone that's being thrown forward on the ice with an initial velocity, so VI is 14 meters per second. And it says it travels for 49 meters, so delta D, 49 meters. Before coming to rest, VF, 0. And then it wants to know what is the coefficient of friction. So remember, once you release the stone with this initial velocity of 14 meters per second, there's no forward force. There's just friction acting backward. Okay, and we're looking for mu. So first step is find A. So use your VF squared is equal to VI squared plus 2A delta D equation. So A will be equal to VF squared minus VI squared over 2 delta D. VF goes to 0. So A equals negative 14 meters per second squared, and remember that negative's outside, so it stays, over 2 times 49 meters. Negative 196 over 98, you should get an acceleration of negative 2 meters per second squared, where the negative just means opposing motion or slowing down. Okay, once you've done that, then you could go sum of the forces in the y direction is equal to MAY, and by now I'm hoping you realize we're going to get Fn minus Fg equals 0, so Fn equals Fg equals mg, and this time I did not give you an m, so you can't find a number even if you wanted to. So now you go to sum of the forces in the x direction. And the only force in the x direction is friction, and it's acting opposite motion, so negative friction is equal to max. But we don't know m and we don't know friction, but we know friction is equal to mu Fn, which is equal to max. And we know Fn, that we just found over here, is mg. So mu mg equals max. The m's cancel, and you can solve for mu. It's equal to ax over negative g. Negative 2 meters per second squared over negative 9.81 meters per second squared. And you should get a mu of 0.20387. All right, that was number 5. Number 6 says a 20 kilogram box is being pulled across a level floor with the force of 120 newtons acting upward at an angle. Our friends the angles are back. All right, so this is a 20 kilogram box. It's being pulled by a force acting upward at an angle, and the force is 120 newtons. This is going to be my Fx. This is going to be my Fy. And it tells us that the angle is 30 degrees. We're also going to have an Fg, an Fn, and friction. The question goes on to say that the acceleration is 3.5 meters per second squared, and it wants you to find the coefficient. All right, so in the x direction, it's going to be cosine, so cos theta equals fx over f. So fx equals, if you want to do the numbers, 120 newtons cos of 30. And if you do this, you get an fx of 103.923 newtons. In the y direction, sine 30 is equal to fy over 120 newtons. Fy is equal to 120 newtons sine of 30. Fy is equal to 60 newtons. Okay? All right. Then we go to sum of the forces in the y. It's going to be equal to 0. And we have Fn minus Fg, and Fy is going up, so it's plus. Fy equals 0. Always trying to solve for Fn. So it'll be mg minus f sine theta. So if you want to get your numbers, 20 kilograms, 9.81 meters per second squared, minus 60 newtons. 196.2 minus 60 should be 136.2 newtons. Okay, so now we go to sum of the forces in the x direction. Equals max. In the x direction we have fx minus friction equals max. And we're looking for mu. So fx is f cos theta. And friction is minus mu fn. And we're looking for mu, so we can bring this over here and this over here. So we'll have f cos theta minus max equals mu fn. And then divide both sides by fn. So f cos theta minus max divided by fn. So I put two steps together here. You could have just solved for friction and then did FFR equals mu fn. But since you know FFR is mu fn, why not just solve for mu? So we have 103.923 newtons minus my m, which was 20 kilograms, my a, which was 3.5 meters per second squared, and then my Fn that I just found there a few minutes ago, 136.2 newtons. And when you do this, you should get a mu of 0.24907. Okay, number 6. Number 7. I don't know where the edge of my sheet is. Number 7. Says a 40 kilogram crate is being pushed across the level floor with a force of 300 newtons downward. All right. Force of 300 newtons downward at an angle of 36.87 degrees. My Fy, my Fx, my friction, my Fg, my normal. And it says the coefficient is 0.3. What's A? Okay, so hopefully by now you know that your Fx is going to be f cos theta. And so Fx is going to be 300 newtons cos of 36.87. Cos of 36.87 is 0.8. Fx should be 240 newtons. And y should be sine. So Fy should be 300 newtons sine of 36.87. That's 0.6, so Fy should be 180 newtons. Sorry, I know I just took shortcuts. Then we go to sum of the forces in the y direction is equal to MAY, which is 0. Fn is going up. Fg is negative because it's going down, and Fy is negative because it's going down. Solving for Fn, it'll be mg plus F sine theta. Mg is 40 kilograms, times 9.81 meters per second squared, plus our 180 newtons that we found. And so you get an Fn of 572.4 newtons. Then you go to sum of the forces in the x direction. So we have Fx minus friction is equal to max. Fx is f cos theta, and friction is mu fn is equal to max, and we're solving for a. So ax is going to be equal to 240 newtons minus 0.3 times our 572.4, which you could have done in a separate step. I was just trying to save time, divided by 40 kilograms. And when you do this, you should get an A of 1.707 meters per second squared. Shoot, I'm still not going to get number 8 in. I was trying. Number 8. I'm going to run out of time. Number 8 is a box being pushed across the floor with a parallel force. We don't know the mass, and the force is 200 newtons, and we're going to have to finish it on the next one.